All right. Hello, everyone. Let's talk a little bit about multiplicity in functions. Consider a couple of graphs here. X squared minus 9 equals 0. If we were to solve that, we would add the 9 to both sides. Or, you know what, maybe you spot that as x plus 3 times x minus 3 equals 0. Set each factor containing a variable equal to 0. And so we get x equals -3 and +3. And so up to this point, I've always said something like, if it's an x squared, if it's a quadratic equation, you can expect to have two solutions. And that is usually true. Here, we would say that these have these zeros. Again, we call them zeros because they're on the x-axis, meaning y is equal to 0. These zeros have a multiplicity of 1. They each have a multiplicity of 1. So x equals -3 has a multiplicity of 1. And x equals +3. Both have a multiplicity of 1. Important to understand about multiplicity is that if the graph crosses at that 0, the 0 has an odd multiplicity. So you'll get questions where you are shown a graph and you have to state what these zeros could be. And that means if it crosses, if it goes through the 0, it's an odd multiplicity. If it crosses and goes through the 0, it's an odd multiplicity. Think about y equals x cubed. Next to Kirby here. That would look like this. We know this parent function. If we set y equal to 0, 0 equals x cubed, well, we would take the cube root of both sides, but the cube root of 0 is just 0. So here we have a 0 at 0, a solution of 0. And x equals 0 has a multiplicity of 3. And again, what's important to understand is that if the multiplicity is odd, you will cross the x-axis. I'll go below here. Let's talk about, let us consider something like x minus, I'll just use this one, x minus 2 squared equals 0. There is no number outside the function, no plus or minus moving us up or down. So we would only move in the opposite direction of what we see, to the right 2 units. And then this is what our parabola would look like, something like this. So here, we do not cross the x-axis like the previous one. And let's take a look at solving this. What are these zeros? You'll be asked to find the zeros from a graph. You'll be asked to find them algebraically. We would take the square root of both sides to free the binomial from the exponent of 2. The square root of 0 is just 0. Add 2 to both sides, and that is our only solution, our only 0. So here we have a 0 of 2 that has a multiplicity of 2. And what's important to understand is that we're not crossing the x-axis here. So if the graph, I've seen people in textbooks use different words, bounces or touches, but the important thing is it is not crossing. So if the graph bounces or touches the x-axis at that 0, the 0 has an even multiplicity. So if we solve this, we get x equals 2. But where's the other solution? We have a squared x set equal to 0. One way to think about it is we have x minus 2 squared, so we basically have x minus 2 equals 0 twice. So the only solution is 2, but we kind of have that solution twice, and we can see that if we're bouncing off the x-axis, the 0 must be even. So let's look at some examples from the homework. Move this up. Let me show you something. Let me change my window in the calculator. So let's say we have x to the power of 4. An even multiplicity. It's touching the x-axis compared to like x to the power of 5. We have 1 0 at 0, one solution of 0, and we cross through. It does not touch and then bounce back down. It goes through. But y, or x to the power of any even number, is just going to touch. It's kind of a weird looking one. But the point is that if the graph touches or bounces off the x-axis, multiplicity is even. If it crosses, it is odd. So here's number 5. Take something like p of x equals x cubed plus 2x squared minus 9x minus 18. Your number 5 will be factorable. So split it down the middle. it's not just x that we're factoring out over here. We're factoring out x squared, leaving us with x plus 2. We have to factor out this sign, and we can factor out a negative 9 from both terms, leaving us with x plus 2 in the parenthesis. So I have x squared minus 9 times x plus 2, and we're going to set that equal to 0 to get our zeros, to get our solutions. But don't miss that this is a difference of squares. X plus 3 times x minus 3 times, I'll just keep it in purple, x plus 2. So, fairly easy to factor, and of course we set each factor equal to 0 and solve. So we have x equals negative 3, x equals positive 3, x equals negative 2. And then it will ask you, what is the multiplicity at each 0? The number of, the sum of your multiplicities will never exceed your highest degree. So these could not have a multiplicity higher than 1. So it will ask you individually, multiplicity of 1, multiplicity of 1. And x equals negative 2 also has a multiplicity of 1. Again, the multiplicity, the sum of our multiplicities, will never exceed the exponent of our leading term. We're going to look at 2 more, I believe. Oh, there it is. Number 6. So write this down. The letter here just randomly generates, I believe. 15x cubed minus 18x squared minus 24x. We have a GCF. And that GCF is 3x. So let's rewrite what we have, set equal to 0. So we divided everything by 3x. So the degree of each term decreased each time. And now you can factor this. Factor what's in the parenthesis anyway. 5 times negative 8 is negative 40. I'm looking for factors of negative 40 that combine into negative 6. That's a negative 10 and a positive 4. Don't forget that this is how we split the middle terms. This 3x will just carry down. But let's do 5x squared minus 10x plus 4x minus 8. And then we factor by grouping. We can pull out a 5x, leaving us with x minus 2. Here, we can factor out a 4, leaving us with x minus 2. Our parentheses must match. I'm just going to keep carrying down the 3x. You're supposed to put brackets around this and the 3x, but these are our factors. 3x times the matching factor of x minus 2 times 5x plus 4, what we took out. And we are set equal to 0. And now we're going to set each of these factors, which contain a variable, equal to 0. If there's no number that you're adding or subtracting, then it's just going to be 0. 0 divided by 3 is 0. Here we add 2. This is a couple of steps. X is negative 4/5. So you can use the calculator to find a lot of these zeros, but something like negative 4/5 you're probably not going to find without factoring. So, and the multiplicity. Again, the sum of your multiplicities will never exceed your highest degree. So each of these have a multiplicity of 1. Let's look at one in which the multiplicities change. And then we'll stop here for now. And here we go. Write that down. We have another GCF. No coefficient, but we can factor x cubed out of everything. So, and we can always set this equal to 0 to solve. Divide everything by x cubed, and we get this. Hopefully, this jumps out at you as a perfect trinomial, like a binomial squared would make that. And that binomial is x minus 3 times x minus 3. You could factor this, set it equal to 0, use the factor tree, But x squared minus 6x plus 9 is x minus 3 times x minus 3. You'll have one like this on number 7. So let's think about the factors as we're going to set them equal to 0. X cubed equals 0. I could take the cube root of both sides, but the cube root of 0 is just 0. But what is the multiplicity of x equals 0? It has a multiplicity of 3. Because I need the sum of my multiplicities to add up to 5. And finally, if I take each of my x minus 3 factors and set them equal to 0, I get x equals 3 twice. Oh, now maybe you thought about it like this. Let me take a second. So if you solved by setting x minus 3 squared equal to 0, just like this, you would take the square root of both sides. But either way, we would get a solution of x equals 3. So however you think about it, factored or not, this way or this way gives us 2 solutions of x equals 3. So we have a multiplicity of 2. And 3 and 2 makes what else but 5? So I'll stop there. But let me know if you have any questions.